I had most of the presentation on the site. I was planning to use the site.
Can you
I can
print
go back to.
can you print the site and save to PDF or something?
I can use the past one before releasing the final one.
Okay, well,
What happens when we are sharing entire screen? Is it? Should I try once?
yeah, try once, and then I think we'll get started because I think we are live.
I can see my screen below. Are you guys able to see that?
I'm not seeing. All right, I'm just going to dive in and get started. Thanks for bearing with the technical difficulties. All right, so welcome everyone. Thanks for joining today. So the goal of this panel is basically to bring together various teams who are helping us tackle questions about measuring the concentration of power across the collective and studying the network dynamics. And for context, probably the biggest overarching question that these various research work streams are trying to get at all stem from understanding how we can ensure that the collective remains capture resistant and fair, or how we can at least minimize the amount of capture. And to recap, in governance, we tend to refer to capture as special interests driving policy or legislation rather than voters. And a couple specific questions that we'll be getting at include, how do we measure the concentration of power? What's a concrete metric that makes sense, that takes into account the different bodies across the collective? What are the various clusters and communities across this network? Can we identify them and understand some of those relationships? And does it make sense to track this over time? What can we learn from that? And worth highlighting that this is an example of Optimism's approach to use data-driven research to design a more effective governance system. And to do this, we rely on a great network of partners. So thanks to all being here today. Not sure if my colleague Emily wants to add anything. She's also been working closely with these teams. Okay. All good there. So yeah, we'll kick this off with some presentations, about 7 minutes per team or researcher. I'll drop in the chat when it's been about 5 minutes. We'll just go in order of the graphic we shared on Twitter. So just to recap, that'll be, first we'll hear from Andres and Amy from Cornell Tech and IC3. Second, we'll hear from Bashak from Bogazic University. Third, we'll hear from Carl from Open Source Observer. Fourth, we'll hear from Yuji and Bilal from University of Hong Kong and Industry. Fifth will be Chainal, who's an active developer and research contributor to the collective. Then sixth, we'll hear from Mel from Stable Lab. Seventh will be Gloria from Karma 3 Labs. And then last but not least will be Max from Web3 Institute. And after these presentations, we'd love to just open it up for a kind of an organic Q&A discussion, following up on different approaches or methodologies we saw, and hopefully leading to some interesting synergies for next steps. So with that, all yours, Andres.
Yeah, thanks, Eliza. I'll go ahead and share my screen. Can people see my screen? That's weird.
Perfect, I can see it now.
Okay, people can see that? Cool. Well, thanks for the intro, Liza. So we are Andres and Amy. We are from Cornell Tech and IC3. And today we're going to be talking about this kind of broader research agenda on like understanding ways of measuring and understanding decentralization broadly across DAOs, and then specifically how some of these ideas apply to optimism and RetroPGF more specifically. Yeah, so as we all know, decentralization is, of course, a kind of central critical property of DAOs, both as this kind of ideal for fair and equitable participation, and it's also critical for security both in terms of like governance attacks and other forms of takeover and so on. Um, Now, before we can even begin to understand decentralization and seek ways to improve decentralization or measure or track, we need an accurate way to compute decentralization and measure decentralization in the first place. Um, so, kind of prior ways of approaching this question involve computing some particular function over how tokens are distributed across accounts. Um, for example, maybe computing the entropy of tokens across accounts or the Gini coefficient, Nakamoto index, and so on. Now, these approaches and this kind of general template of some function across individual accounts has some kind of important conceptual gaps. For example, it may be the case that there are whales present in the DAO. So it could be the case, and I'm sorry for the images being a bit pixelated. We had to like upload locally. So it may be the case that the DAO looks very decentralized, but in fact, most of the tokens, most of those accounts are under the control of a single entity. Or it may be the case that the DAO looks decentralized, but in fact, most voters are apathetic and are not participating in decentralization, and thus a handful of entities are driving decision making. Um, or maybe the DAO looks decentralized, but in fact, most accounts have been bribed to vote a certain way, and other forms of kind of centralization that are not reflected in individual accounts. And in general, there's kind of this notion of subtle centralizing forces, such as whales, bribery, and so on. Um, Whales and so on that are not captured in by looking at distribution across individual accounts. Um, so kind of the work that we've been embarking on is like, how can we measure decentralization in a way that accounts for these subtle centralizing forces? And can we derive sort of theoretical and practical tools from this more accurate decentralization metric? So this has been the focus of the work in our group for a little bit now, and our work has resulted in this metric that we called voting block entropy, which we pronounce VIBE, which is our attempt at a more accurate decentralization measure for DAOs, and we'll see how this applies specifically to optimism later in the talk. So what is VIBE? So VIBE is based on like a simple but powerful foundational principle, which is that instead of measuring distribution of tokens or voting power across individual accounts, we should be focusing instead on sort of blocks or groups of voters that are aligned in some way and are thus acting as a kind of single voting, abstract voting entity. So, as mentioned earlier, things like whales or bribe voters or so on can be thought of as quote unquote blocks of voters with aligned incentives that are driving decision making. So, more formally, we think of aligned voters in terms of their utility functions. So, utility function being kind of the mathematical representation of their interests and incentives across a set of elections. So, in very simple terms, the way that our framework works is that we introduce this kind of pre-processing step where we first cluster the individual accounts based on their utility functions, and then we compute some measure over the distribution of tokens on the resulting blocks. So it's sort of a very simple template, which has pretty powerful applications. Um, and critically, this is in fact a framework that can be instantiated with different clustering functions, entropy measures, which are application specific. So this is sort of a family of metrics in some sense. So this is the kind of central idea. But a core question, which probably many are asking, is we can't even measure utility functions. So what even is the point of this? We don't even know our own utility functions almost often. So what is the point of this? So there's kind of 2 points. The first being that we can derive theoretical tools, but in the interest of time, I'll skip that. And more importantly, we can estimate utility functions via other observable variables on which we can then perform clustering. So for the sake of this talk, we'll talk a little bit more about the second one, but we've done some other work also on the first half. So how do we actually use VIBE in practice and for optimism and so on? So as I said, we can estimate latent variables like utility functions based on observable variables. So the most natural example of an observable variable is the voting history. So voting history represents the direction, if you will, of a voter's utility function on a specific election. So the kind of core idea is that similar voting patterns across many elections is indicative of centralization between entities. So then how this works is that we can represent or estimate a player's utility functions based on their vote. So, vote yes, abstain, vote no, and so on. And then with this vector of binary votes, we can use some clustering function like hierarchical clustering and so on. Uh, and then compute something like min entropy or Shannon entropy, etc. Actually, I will, one sec. Okay, can people still see my slides?
Yes, we can.
Okay, cool. Okay, so now that we have this, kind of practical instantiation of our framework, which again is based on just using, in this case, we're using voting history, but as future work, you could imagine using other forms of data. What can we use this for? So there's kind of three natural use cases. One, just simply tracking decentralization. Two, understanding voting networks. So looking at the first part of the framework, once we have these clusters of voters, trying to reason about the dynamics of these clusters. And the third part, which is the most relevant for this talk, is as part of governance experiments. So with a accurate decentralization measure, we can now investigate how different mechanisms affect increase or decrease decentralization. So now, how does this apply to specifically RetroPTF? So I'll switch gears to Amy, who's going to talk more about this.
Cool. Yeah, I'll summarize this really quickly because I know we're short on time, but OVIBE essentially is basically calculating the entropy of voter clusters. And how you can interpret this is that higher OVIBE just means more decentralization, and a lower OVIBE means more centralization. And so this is the framework. But now to apply this specifically to optimism and RetroPGF, there's some specific tailoring or instantiations that need to happen here. So what we need to do is basically take some input data from RetroPGF. So this is a vector of like voters, the projects that they're voting on, and then some amounts that they're allocating in terms of funding or voting power. And then we're doing some clustering, which might look like bag of words. It's very similar to the literature that's coming there from the algorithms that we're using. And then finally, we're performing entropy calculation, which the one that you decide to use will depend on the specific context of the experiment. And this turns into something really cool because now that we have this instantiation, we're equipped to run a set of different governance experiments and also answer questions based on those experiments. So for example, does having the existing voters versus guest voters change does it increase or decrease the centralization of the voting? Or if we randomly assign voters to different projects, does that also have a shift in vibe? Or if we have voters voting on specific project categories, how does voter decentralization change? And finally, if you increase the amount of time that people have to talk to each other before a voting round, does that increase or decrease decentralization? So OVIBE becomes this metric that allows you to actually measure based on changes to those experiments in RetroPGF, whether there's a change in decentralization. So really quickly, there are a few considerations for these experiments, which include which algorithms to select, how to handle sparsity of data, and also interpreting results. But basically, we're just following best practices in terms of what the data actually looks like. And also in terms of vibe, again, this is identifying alignment and not the cause of alignment. And it's a great metric for just comparing across different rounds of RetroPGF. But also it's important to note that knowing the context of what's happening there is really important. So with that, I will wrap it up. There's some documentation for GitHub repo and open source code that you can use to look at the work that we're doing. And I will pass it back to Emily or whoever is in charge for the next presenter.
Thank you so much. That was great. And yeah, bear with us as we, keep things moving along just because we have so many great presentations. But thanks, Emily, for keeping track of time. Now we'll go on to Bashak next, followed by Carl.
Okay, hello everyone. How do I share my slides? It's uploaded. It's just okay. Thank you. So, hello everyone again. I did prepare my slides on a slightly different way. So I basically prepared maybe I misunderstood the objective of this panel, but I prepared my slides to basically handle basically to answer the question of how this data can be studied. And these are some of the suggestions that I have. When I first joined this initiative, I was given the following hypothesis, which is guest voters come from a more diverse social graph than citizens, or citizens are more networked with each other than guest voters. And to answer that question, I basically immediately thought of using multiple network metrics, but the problem was that the data is so large, and in my university server we don't have so much computational power. So I decided to do the following. I created a subgraph of ego networks of citizens and guest voters and their immediate neighbors, and even that was still a very large graph. And one thing that I haven't yet tried, but like to take the backbone of that graph and basically look at simply the ratio of intergroup connections to all connections. And by intergroup connections, I mean citizen to citizen and guest voter to guest voter connections. And we can simply look at, the number of triangles of guest voters and citizens and the clustering coefficient. That will definitely give us the exact number of connections that citizens have to citizens and citizens have to guest voters. And a more interesting thing could be also to identify communities and calculate the Krackart's internal external ratio, which basically looks at the links within the community, that is intra-community links, and it takes this ratio to extra-community links, which basically tells you how compact the community is with respect to the outside, the rest of the network, so to speak. And actually, basically, I'm going to expand upon what we can do for the future given the governance aspects. This is not something that I had prepared in advance. So I think it might be useful to look at the temporal dynamics using temporal exponential random graphs on a more basically simplified network. This kind of methods can help us to basically calculate the propensity of guest voters to form ties to other guest voters. And for example, if at time t, a guest voter who is linked to another guest voter becomes more likely to contribute to a particular Git repo, for example, at time t1, that might be an indicator of strong ties and a propensity to basically work together among nodes of the same type referring to citizens and guest voters. And we can definitely do the same thing for citizens as well. And having identified, this propensity, it might be possible to basically do, I don't know if it is possible to interact with these users, but maybe do a survey or something in order to identify the motives behind voting patterns. Because thus far we have what we can call an observational data in social sciences, which doesn't help us to identify motivations behind behavior, but yet we can still make predictions about the most likely type of behavior. I think I'm going to stop here. Thank you.
Great, thank you so much. And Carl will be next, followed by Yuji and Bilal.
Excellent. I'm just queuing up my presentation right now. Is that working? Can you see? Oh, let's try this. There we go.
Yep, looks good.
Excellent. It's so nice to be here. My name is Carl Servone. I'm one of the co-founders of Open Source Observer. I really loved hearing Vasek's presentation just now because we collaborated a couple months ago to seed some of that initial graph data. And at Open Source Observer, the thing that we are trying to do is build a network of impact data scientists that can do work like Vasek just illustrated, as well as solve a range of other thorny governance problems so that ultimately we can use open data for smarter collective decision making. The reason that we are here, and I speak on behalf of my team at Open Source Observer and what motivated us to work on optimism and pay attention to these problems, is that we care deeply about measuring impact and doing this in the open. We don't really want to just sit in a room and try and pick the winners and losers. And so experiments like retrofunding and any program that is allocating capital across a range of decentralized contributors is really interesting to us. We think it's a hard problem, but we also think that in the long run, open source network economies are going to out-innovate, out-compete traditional corporate structures. So that's what motivates us to be here. As I said, the thing that we are doing is trying to build a network of impact data scientists who can use a mix of on-chain and off-chain data to maximize the amount of positive impact that is created per unit of OP or other tokens that are spent, that are invested. So that's the thing that unites us. That's why we're here. What we've done is we've assembled a whole range of different open source data sets. Our entire pipeline is fully open. Anybody can verify where the data is coming from. They can add and connect new data sources. They can build models on top of it. Again, they can inspect the source code, but they can also use the infrastructure as a public good. And so we have a number of teams that are taking advantage of this. Again, some on the call today. And we've tried to create tooling which makes it easy for any data scientist to come in and get started and use the data in their environment of choice. Now, as I mentioned, we have a mix of off-chain data sets. That includes everything from GitHub data and the whole software supply chain dependency tree to a range of on-chain data sets, including everything on the superchain, as well as other Ethereum layer 1 and layer 2 data sources. The other thing that we've done is try and create a registry of projects and collections of projects that kind of brings together both their on-chain artifacts, like contract addresses, deployers, as well as their off-chain artifacts, like GitHub addresses, packages, et cetera. And this has been used a lot in retrofunding. We see that as just one of many potential ways of improving decision-making. But ultimately, the goal of a program like retrofunding is to optimize the allocation of capital more effectively. And we think that data can play an important role in that. The problem, though, is that right now, the people that are interested in governance and the whole kind of public goods problem space, and the people that have these kind of data science skills, there's very little overlap between those two communities. I think that we're lucky that we have a number of those people that are here on this call today, but outside of that, it's a pretty small community. And so we are very eager to try and grow the size of that community, create resources, as well as programs that can help onboard new people with data skills, get them excited about public goods problems, and then on the other end, take people that are interested in improving governance and help equip them with data skills so that they can make an impact. So that's what we're focused on here at Open Source Observer. Again, the thing that we are looking at specifically when it comes to optimism governance, we have a series of blog posts that show some of the insights that we've published recently. Most of them are looking at retrofunding, but ultimately what we're trying to get at is ways of identifying the impact preferences of different constituencies within governance. So if you take the badge holder set that is voting on retrofunding, there are different opinions around which team should receive the most rewards. Should it be a kind of broad set of projects that are eligible, or should it be a much more narrow one? There's also questions around what the distribution curve should look like. Should it be a flat distribution, or should it be much more of a power law like you see in this exhibit over here? Then there's also the question of what metrics are predictive or relevant to helping allocate funding across a range of projects. There's some views that think that you should reward kind of outright adoption as one one category. Others would argue that you should be looking at the rate of acceleration, how fast is a project growing. And then there's also views around it should be based on kind of the reputation or the utility of it. And that might not correlate at all with how many people are actually using it or the rate of growth. So there's different schools of thought around what metrics are most valuable and how they should be weighted. And then ultimately what we want to be able to do is create tooling and insights that enable people to express those preferences and then reveal them through some type of a voting interface. And then over time, as we run more and more of these experiments, we can actually see which types of voting strategies correlate with the most optimal results over time. So it's a really exciting design space. If you're interested in contributing or helping out, the best way to get in touch is to reach out to me. This is my Twitter handle. You can also look at our docs and our website at Open Source Observer. Most of the things that we're doing are kind of behind the scenes in the big data lake that I described earlier. So our website is a little bit lagging, but all of the docs are up to date and give you an overview of where you can start getting data and how you can contribute. Thanks so much.
Awesome, thank you. Yuji and Bilal, all yours. I can't hear you. Benji, do they need to be brought to the stage?
Hello, can you hear me?
Yeah.
Okay, cool. Cool. Thank you for having us. It's an honor for us to participate in this critical mission. Our project, Voting Influence and Concentration Analysis, or VICA, is tailored to meet the needs of the Optimism Collective. It is a methodology that evaluates the influence of voting blocks on outcomes and assess the degree of concentration in governance structures. This two-part approach begins with the clustering analysis of voting activities, where we detected potential communities across the network. Then we estimate explicit voting influences through logistic regression. In addition, we combine counterfactual analysis and logistic regression to estimate the implicit voting influences. So up to here, we get distributions of voting influence from the results of logistic regressions. All of the analyses are conducted on top of the voting blocks. The second part constructs various concentration matrix, aka VICA concentration score. We did this by analyzing statistical properties of voting influence distributions. We use like variance, skewness, and also evaluating metrics such as Gini coefficient and entropy. The degree of concentration is more of a relative value that you should have a benchmark or history to compare with. So VICA is designed to run regularly, and we will have a time series of concentration scores to monitor the trend over time. Our methodology and code base are all open source, and we welcome any suggestions and collaborations to push this project further. In addition, we implemented a Twin dashboard to visualize the results. So now let me hand over to my teammate Yujie to talk more about the modeling details. Yujie, now it's yours.
How can I switch to the slide 2? I cannot. So I upload 2 documents. How can I just open the second one? Remove. I cannot open the second slide. That's weird. So maybe I just I just start from using slide. So let me see. Sorry. So how about I can just yeah. So this flowchart just basically introduce our main work. So it can be from two parts. The first part is the complex network, which is to do the clustering, so that we can have some group information. And because we see each node in uh, the each node is a address, and also there are some relation between each node, which we call edges, and we use some similarity to define the weight of edges. And by the measured complex network, we can do some community detection, and we can do some clustering. And for the second part, we do the logistic regression for each point. Finally, we will get individual effects for each point. And this can be viewed as a power for the individual to the outcome of a proposal. And then we end up the group information and the individual effect, which means if those address, if they are in the same group, we just assign them the same the same effect, which is a mean of the individual effect within the same group. And then we can have a group of data, and we can define some centralization metrics like the variance or Gini coefficient and other metrics. So basically, for the details, let me see. Sure. So how to go back to the slides? Let me see. Slides. Let's move. Project report. Sorry, I don't know how to show my slides on the screen. I have already uploaded those, but why this doesn't work? And then, okay. So maybe I just briefly talk about some details. So we first do some filtering for the data, which we quantify the activity of address by the total number of vote cast. If if it has participated in at least 5 votes, we see it as an active address. And then we do the clustering analysis. The similarity between address I and J is based on the number of votes they cast identically across proposals. And after doing that, we can do the community detection by some algorithm. Okay. So the time is up. Maybe I can pass it to another one. So yeah. Okay. So we do the community detection. So we have some groups, and then as long as we can do logistic regression to identify the individual effect, and by the group information we can add the information of group into the effect, and then finally we just use some metrics to measure the variation of the power of each nodes. And so,
All right, thanks so much. I think because we're at time, it probably makes sense to move on to Chainel, and I'm actually already seeing that presentation being shared. But thanks, Eugene, Bilal.
Hey, good morning, good afternoon, good evening, everyone. Thanks, Bilal. Thanks, Emily, Eliza, and everyone from Optimism team for organizing this wonderful panel. I'm right now attending like this part of here is India Blockchain Week. I'm attending over here, and I don't see anything which works towards actually moving towards decentralization. So the work which we have done is to measure how the concentration of power flows across all the DAOs. So obviously, when we say we are Ethereum aligned, we always like decentralization, and with this specific work which we have done, we've tried to come up with a number which can help participants of the DAO understand how can we actually make the DAO more decentralized. So for this approach, currently what you see on my screen, this is a site dawcpi.com where we have hosted all of our work. So the methodology which we have used, it has been influenced from Herfindahl-Hirschman index, which is used in economics to measure concentration of few companies in a market. Whereas in DAOs, we do not have companies, but we have delegates. So our challenge was how do we translate the influence of delegates into uh, a number which can say that okay, this is the influence of this specific delegate, and if their delegation is increased or if their representation in different house or council is increased, then perhaps we are moving towards not decentralization but moving towards concentration of power. So the outcome of it, as Bilal also mentioned, most of these calculations are relative only with history. So if we don't know the history of how the score would have been with whatever calculation we are doing, then it is difficult to measure where we are heading. And what you see on my screen right now is calculation of CPI based on the method, which I will describe it further, where initially we started with a CPI score of 143. In HHI, it is generally between 0 to 10,000, but here it has to be different. So it started from 143, and as we are moving from one season to another season in Optimism, we see that the concentration is decreasing because there are more and more participants who has influence over the collective in terms of being in token house, being in citizen house, being in grants council, and so on. So, in order to come up with this number, what we did was sharing my another screen. I hope it's visible. Uh, okay, yeah. So we try to give few important parameters for getting a score of each token house, citizen house, grants council, M&M, security council, code of conduct council, developer advisory board. Yes, all of these are part of Optimism governance, and obviously that is why I think Optimism is leading it. And when we give number to all of these weights, we get a score that the influence of token house is 32%. So if at all a delegate is over there, they have this much influence. If there's a citizen house, badge holder, they have influence over allocation of OP via retrofunding or any other means, which as we move forward in governance, we'll explore. And based on these numbers, we move on to giving each delegate an influence score. So going on to explore index part of dowcpi.com. When we go there, we see that the top delegates have voting power. Let's say the second delegate has 5.47 million OP. Their influence in token house is 5.29%, but overall influence drops down to 1.7 because they are not part of citizen house, or probably they are not part of grants council, and so on. Hence, we pick this influence score, square it up, add it all, and the final index which we see is a simple number which can help anyone, any basic participant of DAO understand that this should always go down and it should not go up. So our entire hypothesis was to come up with a simple number, just like Google had PageRank, which allows anyone to understand what is happening. How should I increase my PageRank? Over here, we are looking at how should we decrease our CPI so that the DAO remains decentralized. So to see it in action, I hope I'm audible.
Yep.
Okay. To see it in action, we try to implement in Cora Club when if a delegate, if a participant goes on to vote, delegate their tokens to another delegate, then they will be able to see what is the change happening with current CPI and the CPI which will be changed. So at the point of delegation, at the point of electing a member to a council or nominating a badge holder, we will always see a change in CPI score. If the change in CPI score tends low, as I mentioned earlier, then we are moving in the right direction. And perhaps anyone can use these APIs. We expect it to be there on mostly used UIs like Agora or Karma, so that DAO participants can see what CPI score is going to change. Obviously, with 3000 OP, it's not changing. But if you change this number to 30K or 50K or maybe 100K, the CPI score will indicate, rather than delegating to the person you are doing, maybe change it and see, and the score is going down. So you would always like to delegate to a person or delegate where the score drops. So more on this, you can find all of our research reports on dowcpi.com. We have a research report observation file behind the scenes, what we have done, the influence calculator presentation, which obviously I avoided right now. Uh, and yeah, that's our work. We would like to connect with anyone who can help us in making this better or making it widely used. Thank you.
Great. Thank you so much. Next will be Mel, followed by Gloria, and then Max.
Hey, good morning. Can you hear me?
Yep.
Okay, cool. Oh, screen share works. This is great. Let me see if I can go ahead and bring that up quick, and I'll try and do some quick talking while I'm doing it. So my name is Mel. I go by mel.eth in the metaverse. I work at Stable Lab. I'm a professional delegate, which means I basically vote on behalf of token holders and try and represent their interests in DAOs. While I was doing some of that and working within a DAO called the Index Cooperative, I came up with a voting methodology that that is referred to as the Oxcart method now. At the time, I was calling it all kinds of terrible things like Gov Blender, and but the general idea is this. Let's see if this share works. Let me know if you got me there.
Yep, looks good on my end.
Okay, cool. So, so the general idea is that everybody picks a backup voter or a delegate. And if you vote, great, your vote's carried through. If you don't, your vote is ported to basically to your backup voter. So the people that do vote carry all the voting capital of the people rolling up to them. So this is essentially liquid democracy. However, every voting path is carried forward. So when you get there, it essentially creates like a Turing complete mechanism for making decisions. So going through, I wrote a paper about this back in March, just outlining that when you're electing, you're participating. When you're so the delegation function itself is participation, and participation itself effectively is a way to delegitimize your delegate by voting, right? So if you create a construct where the only mechanism to delegitimize is by participating in some other capacity, you get 100% participation from a group 100% of the time, subject to some apathy loop type of rules. I talked to Michael Zargum over at Block Science. They spec this up as a math spec for us, and this was just their largesse. We're really grateful for this. But this enabled some of the next steps, which were getting some smart contract design done. I went out and spoke about this at MetaGov as well, trying to basically balance out how to create a balancing function between the many and the few, the one and the none. And so if you're interested kind of in more of the theory, it's there. But where this got us was a funded project on Arbitrum. And so we had to apply a little bit of incentive here. But really what this highlights and shows, and this is live, so you can go here. It's dashboard.force.io/oxcart. And it shows at that DAO who the voters with the most voting capital are, and then how they're supported within the group of the top 100 delegates there. So intra-delegate support becomes the sort of the defining feature. And so at first we said, okay, everybody go pick a backup. Well, getting delegates to do anything is like herding cats. And so we got about 10 to do it over the course of the project, even with incentive. So we had to come up with a methodology to create a fully connected set of delegates otherwise. So we use similarity scores. So basically, how did you vote within the last 50 votes? And if that's using those scores, we created this directed graph to carry all voting power forward. And what we found is that it reduced participation, but basically that lazy participation. So what is effectively the transitive property of trust, meaning I trust you, you trust somebody, right? So I trust that somebody, some amount, it's not zero. And this is what we're trying to explore. So if you carry through that participation of transitive trust through extreme delegation, meaning everybody's delegated in a sense, you get a reduction in the voter apathy by about 45%, meaning all of those who weren't participating before are now participating through delegation. And then, and the cool thing is you only have to do this to like your top 100 delegates because they represent, 98% of your voting power. You could do it with the full community if there's a desire, but it's somewhat not necessary. And then again, we pulled this chart together to try and show delegates, basically, who would you delegate to within your intra-delegate environment? There's only 6 within that DAO that were early and often. So this shows how often you vote, how often, and then again, how early or late within the voting period, within the active voting period. So if I were going to delegate to somebody, I'd want to delegate to somebody that's going to vote early and often so that I know what their choice is going to be and if I want to pull back and make a choice myself. So essentially, really at the heart of this is mathematical legitimacy. This is a paper that came out of that experiment, as well as some of the theoretical concepts that went into it. And the gist here is that formulating a theorem for how we legitimize each other, and this is so simple in theoretical terms, where it's like your legitimacy now is equal to your legitimacy 5 minutes ago, plus all the changes that happened in the last 5 minutes. It's not as complex, but what it does do is it allows us to get to a place where these types of relationships, we can basically call them voter authority relationships. All of these, this entire graph. And by studying that, we get to a place of saying, how legitimate is the whole? And then, how trustable are we in relation to each other? And so, yeah, thanks for letting me present on this. And ultimately, I just want to say optimism this is already happening. So a fully cascading delegation environment is happening at Optimism. And this methodology would allow really advanced, I would say, meta governance capabilities. So being a super chain, chain of chains is the feature that's going to allow these advanced delegation strategies to persist. Because if you can port mathematical legitimacy from one chain to another, you're effectively, transposing governability. So thanks.
Hello. I guess I'm the next. I'll make it quick, and if there's any questions, we can go back to it. So I'm Gloria from Commerce Labs, and the project we're building is called OpenRank Protocol. So what is OpenRank? It's a reputation protocol using traditionally called like PageRank algorithm suites such as Eigentrust and Hudson 30 and a suite of algorithm like that to apply to a graph data and surface who are the reputable users, reputable objects in this network. And we adopted innovative ways to make this computation of the trust scores verifiable permissionlessly. So this is offering like super resistance and providing like context-specific reputation indications for different kind of use cases. And we've done like file cluster graph users based on their engagement with each other, so we know who are the more reputable users in the file cluster graph based on the trustworthy engagement they have. So we surface like this kind of like rankings for different use cases and used by like more than 100 projects on Farcaster, and also Optimism Ritual 4 also used the Farcaster user ranking by OpenRank to indicate trusted users. And we did this to GitHub activities together with OSO, and was able to surface the rankings of GitHub developers. And this was again also used for Ritual 5 in the last rounds. And then recently we did like a Clunker token score for which tokens to trust issued by Clunker bots. So this is a little bit context of OpenRank. We're not necessarily the best in data visualization, so I really hope that some of you would collaborate with us and take some of our work further to generate more useful insights for this exercise. So this analysis at hand is to do modularity analysis for the Optimism citizens and guest voters based on their Farcaster social graph. So the hypothesis is that if they belong to the same social graph network groups, they're more likely to collude, and they basically doesn't represent diversity. So when we want to contrast those two groups and see what we can find. The general method is using the OpenRank Farcaster social graph, which used the Eigentrust algorithm, and we use the engagement graph. So a eigenscore from, let's say, one node to another will indicate how much this first node trusts the second node based on how much engagement activity they have. And we have a weighted formula for that. And you can go to our website documentation to see the exact algorithm. And there's also APIs available for indexing that data. So there are two approaches we try to explore. One is to visualize the data directly. So the blue nodes here are citizens, and the pink ones are guests. If I share this tab instead, this is a live graph history visualization. Supposedly, we can do a lot more analysis here. Yeah, but because our team is not the the expert in visualization, so someone else please take this forward. I think it's a lot more, it's very interesting to continue this work on this approach. But I'm going to focus on talking about the second approach, which is personalized forecaster network analysis. So it's very simple. So we run eigentrust for each node individually and generate a list of all of their top 100 trusted peers. And there is a score assigned to each peer. That is basically the basis for the quantifiable analysis that we're going to see. And then we try to identify the degree of overlap between the lists to find like whether members belong to the similar social group or not. And this is the data we used. There's a CSV attached to this doc. A source node, they are the forecaster nodes that either a citizen or a guest voter. And the target nodes are the top 100 forecaster friends of this source node. A source target eigentrust value shows the trust score from the source to each one of these top 100 targets. So what did we find? So one, the trust dynamics by relationship groups are quite different. Like as you can see from this graph, citizen to guest trust is lowest, which means sort of like they don't really know these guests as much. And the citizen to citizen trust is the highest, which means they do belong to, more likely to belong to the same social group. What is interesting is that, so the guest to guest trust is relatively the second lowest. So they're not as connected on the social graph. But the guest to citizen trust scores are relatively higher, second highest, which means they kind of like, they actually give a lot of interactions to citizens, but there's a asymmetry in this trust relationship dynamics. Yeah, these are like the breakdowns of these scores. And this is basically a little more elaborated findings than what I just said. Second interesting thing is the overlap of social circles. So yeah, we basically just kind of like compare the lists and see how many people are kind of overlapping on those lists. Citizens only category a lot higher, and guest only category a lot lower. So this basically means that citizens and guests belong to largely separate social circles with some overlap, and citizens dominate the network in terms of exclusive relationships, while guests show a smaller, less defined network of unique interactions. And then the last one is network clustering analysis. So this is not as mature, but it tells a little bit of a story. If we investigate into like the size of the networks, obviously we're only cutting off a fraction of it. We're only taking the top 100 of their closest friends. So we can reduce the size and do some analysis. So the citizens only group kind of like has this really big, significant larger cluster than everybody else. So this one has more than 2,000 connections in this group. So yeah, that's basically the bulk of my analysis. I would stop here and make this document available and this visualization also available for further collaborations. Yeah.
Awesome. Thank you. Yeah, this is all so great. And we have one more presentation for just a couple minutes of discussion and Q&A. So the final presentation will be Max.
Hello. Thank you. Thanks for the invitation. I'm Max. I'm a researcher in the governance space associated with the Trusted Seed Web3 Institute and Region Network. So this project I'm presenting is the collaboration with General Magic, which I built in public goods. Lately, we were working already with some governance through Region's core, which were attestations on chain of the regenerative activity, like donations. And now GovGraph is a new thing, which is a visualization of citizen and delegate connections. So it's based on the network analysis that studies relationship patterns between entities in a network by examining different connections and various properties like centrality, density, and clustering. We took various on-chain data like registry of citizens and delegates, Farcaster connections, token holdings, like some specific tokens, attestations, some off-chain data as well. So the resulting graph can enhance our understanding of the dynamics, and it's also can be used by different parties for like partnership or policy management or voting, onboarding, token distribution. So let me show you around and tell you about the insights we found so far. So first of all, you could see this is a combined map of citizens and delegates. Citizens are white and delegates are yellow. So these are unconnected nodes, and these are those where we have identified connections. So what you could see first, like if you look at the only citizens, the density of connection is much higher. There's only like small percentage of people who have no identified connections, unlike in delegates. And we took only top 1,000, so there's way more. But in here, the core density core is like smaller connected, like compared to the total size of the group. Again, this is not all the connection. Maybe we don't see something, but in the same comparison, we can, analyze the two groups. So the other insight was like the node size for the delegate represents the size of the delegation. For the citizens, it's the amount of connections for now. But you could see that there is basically a cluster right here of powerful delegates. And if we enable like with citizen view, you could see a lot of them are associated here. So they are located more in this group. And even if we see only citizens, a lot of citizens you could see in the center, big citizens are delegates. So there is like this powerful cluster, you could say. And finally, like one of the use cases we initially were curious about, and but we could extend it for any other demand, is this various different on-chain behavior, not like only connections, but for example, through monitoring some connection with, for example, the on-chain, like off-chain list of trusted seed, our community, holding of the TEC token, receiving the like we create a list of POAPs in region, so who was attending region events, and who minted the on-chain attestation, and basically all of their friends is a way to represent maybe like a cluster of regenerative people, so we can maybe know who to go to. But that may be any different group, it can be some technical direction or whatever. So that's what we have for now, and you can, you could see each, if you like, you could see details or search if you need for a specific person in here. We're looking now to work, advance this work with like Farcaster Sybil identification algorithm grant that we got from OP. And for this, we also thought to add governance roles, so participation in the governance circles. It doesn't have guests, but it's not too hard to add guests now. And also Gitcoin data might be also curious to work with. Very thankful for your time, and please, if you have any questions or want to suggest anything, please get in touch. Thanks.
Awesome. Well, thank you so much to all of these teams and researchers, both for being here today, but obviously for all of the work up until this point that you've been doing and helping us tackle these pretty mission critical questions. A lot of interesting stuff was shared today. A lot of brain power on this call. Definitely energizing, and very fortunate for us to be able to collaborate with you all. Wanted to just close this out with probably like 15 minutes of Q&A or discussion, both among the participants. But also, if any audience members tuning in want to comment on Twitter, I think Benji will be monitoring that and drop those in the chat. So feel free to also drop some questions there. But yeah, just want to first open it up to anyone here on the stage to ask questions to one another. One high-level question on my mind is just whether folks here see any specific collaboration opportunities moving forward based on what you've seen. Yeah, I'll open it up now.
Yeah, I'll bite.
Let's go ahead.
I was just going to say, I think GovGraph, which I've played with before as a badge holder, is really cool. And given that the different methodologies for connection within the graph are, again, I think really intentional. And the basis of what I've been working on Oxcart is simply, who do you trust the most? Just asking that question, and very directly. It's really cool to see that adding one button to something that already exists is basically possible. And so this has just been really enlightening today.
Yeah, I just wanted to say, it feels like a missed opportunity. This is the first time that many of us are meeting. I think there's so much that we have in common. And in many cases, we've been kind of working off of standing on each other's shoulders without even knowing it. So I definitely like to see there be some kind of substrate for this group to do more things together. Because one thing that's definitely clear to me is that each of us has our own strengths, as well as areas that we really have no interest in doing ourselves and would like to get the community to help out. So, Gloria, as you said, you've kind of worked on top of data that we're trying to curate. You have no interest in building up these massive index data sets. On the other hand, you're trying to create the most effective algorithms and generate insights from those, but you don't want to touch the visualization aspect, which is really important for people to understand how those things are going to be used and what impact they'll have in different communities. So I just see a lot of synergies, and so I hope we can do more things like this in the future. Thanks, Eliza, for bringing us together.
Yeah, no problem. I will say, just quick 2 fingers on that. I'll probably be asking each of you, if you'd like to join some type of group Telegram chat. We can jam more on these topics together. So that can be one concrete, small next step to hopefully lead to more research, further steps.
Yeah, I also wanted to mention that I made some notes we need to integrate this and that through this call. So I'm really happy that I could hear you all. And I also marked to speak more with Gloria about the interfacing some of the graphs.
Well, one question I'd love to put to this crew is how are you thinking about basically almost like the metric target automation sense of things when it comes to measuring centrality? One thing that became really apparent in my testing is that when you make really explicit how to influence something, in a voting construct, not everybody reacts positively to that. Maybe those that are most able to influence don't enjoy that type of transparency. So that being said, it gets me to a place of, okay, we can apply vote accounting methodologies that make things more maybe distributed and fair. So let's say we apply quadratic to the top 100 delegates. No matter how much voting power you have, whatever your place is in that ordering, you get a quadratic allocation of voting power that is, determines how we decide things. So it's almost like an 80-20 rule governs. Again, what DAO would vote that into existence, right? If you can buy your way into maybe a higher slot, sure, but you still can't influence at the state of where it is now, where most DAOs have like 1 or 5 people, 1 or 5 accounts, that really take the charge on controlling the DAO. And so, yeah, I kind of put that question to the crew because where it gets me is you can reallocate voting power after the fact, sure, or you can take those measures to ensure that it's distributed well, kind of, with foresight. And where do we meet in the middle on some of these things, or how do we try and bridge that gap to get from here to there? Because in essence, almost any delegation construct is an admission that voting power distribution needs to be thoughtfully reallocated in process. So I'll leave it there. Did I break the chat?
I mean, the other thing that I would say is that, like, these algorithms, they're kind of important to test out, and people are going to have various ways they might want to weight things, and they might want to experiment with it. So anything we can do to like make it easier for people to take a model and either kind of test it out or fork it or build on top of it would be really great, because I think that like the best insights are probably going to come from having a network of people kind of trying out different configurations and experiments, as opposed to any one of us just like coming up with our best shot at it.
I love that. Yeah, open source is the way, fully.
I don't really have specific comments on the mechanism, but I think from what we have observed this year especially, depends on the kind of decisions we need to make. I think there's also a differentiation between expertise and social connectedness. In a way, I would feel like citizens, or yes, especially citizens, they're in the same social group, probably it's outcome of them learning about governance together, right? Or exchanges that they had to do together for the collective when it comes to governance. So they probably would be still, well suited, even though they're not like super decentralized, to make certain governance related decisions, but probably not other types of decisions when it require other sorts of expertise or needs a more decentralized, diverse background to factor in their opinions. I think it's really context specific, which makes this interesting but nuanced, but also complex.
It's wild, because in this complex space, usually the thing we're trying to get to is yes or no, right? Like It's a very complex thing that comes down to a super generally binary or very small output set. And so yeah, in that context of like, if the early often voters sort of lead, maybe, right? Or if the early voter gives better signal than the late voter, every voter that votes the same way after the first voter that votes yes, or the first voter that votes no, are they just affirming the first vote, right? Or it's ways to kind of, I don't know, thinking through these things is just really interesting, because again, I do think there is a huge social element, even when there is expertise involved, like you said. And it's really interesting that you called out like coming up through together, right? Like it's even how we became, badge holders is through an affirmation function of, I believe this person is well suited to be a badge holder. And then that's how the network grows. So yeah, it's pretty cool.
And something I appreciate about both Gloria and Mel's comments is they touch on kind of this need to take all of these great analyses and metrics and things we've come up with and think about what does that mean in practice for continuing to iterate on the design of the system. So I think that could be a really interesting space and conversations to continue to have. And to Gloria's point, being very clear about how are we interpreting each of these different parameters and defining them and what goes into those. So yeah, certainly a lot of great work done here, and plenty remains to make sense of this and continue to design. Let's see, I haven't seen any audience questions come in through the chat. Not sure if anyone else has any final last questions for each other. If not, no worries. We'll start that Telegram chat, and this won't be the last time, hopefully, that we're connecting and jamming on this. Just give a couple more minutes if any other questions come up. Cool. Well, if not, let's close there. Thanks again, everyone. I know we had some folks tuning in from some pretty inconvenient time zones as well, so big shout out there. Awesome. Thank you all.
Thank you. Thank you for hosting.
Thanks, everyone. Really cool.